Hi, I'm Su, and I'm gonna to explain my class transfers, and then I'm gonna to explain my idea about some text. So the first one is for store the age of graph by urgency matrix way. The string node is the name of the node in the graph. Int number vertex is the number of the vertex in the graph. And int number age is the number of the age in the graph. Additionally, bool is a type that only holds two values, which are true and false. So it's mainly used for judge if it's true or false. And the last one, the length of the string, I use it in test 12, which mainly for compute and compare the values to pick the minimum weight age. And I saw that it just need to explain 1 to 2 questions of tests in ED discussion. So I choose the last two tests to explain, which are test 11 and test 12. So in test 11, I use the first transversal method. The general idea is for transversal graph to say if there is visited vertex, and for every visited vertex, if there is an adjacency, U is already visited, and if the last parent of vertex, there is a cycle in graph. So we can start from vertex A, we can mark it as visited, and there are three neighbors for node A, which are B, C, D. So we go to C first, and the parent of C is A. Also, C has two neighbors, which are A and D. Then we go to D and mark it as visited. We can say that D has three neighbors, which are A, C, and E. C is visited and is parent of D. We also have A, which is visited, but it's not parent of D. As a result, we can say that we found a cycle, and the rest is the same idea. And then it says the code. So the first part is useful to mark the current agency as visited, and the next part is useful to say if an adjacency is last visited, and then we curve for that adjacency. And this one is say that if an adjacent is visited and it's not a parent of current vertex, then there is a cycle. And for test 12, I use prim method. The main idea is that so firstly compute the length value between each vertex, and pick the vertex with the minimum value, which means the shortest distance to the current vertex, and add it in the graph. And when the vertex number of the graph is the same as the vertex number of the original graph, we got the minimum spanning tree. We can start from A. We can say that A has three neighbors, which are B, C, and D. The value between A and B is 6, between C is 9, and between D is 1, so we pick D. And D has three neighbors as well, which are A, C, and E. The value between D and C is 7, and between E is 5, so we pick E. Then we go to B. B has two neighbors, which are A and E. The value between E is 3, which is less than the value between A 6, so we pick E. Lastly, we go to C. C has two neighbors, which are A and D. The value between C is less than that between A, so we pick D. Then we go to the minimum spanning tree. Yeah, that's it, and hope I explained clearly.